So TLS also has a nice property called end-to-end security. And this is finally the place where we can go back and guarantee security on all of those previous schemes that we saw. So remember when we talked about layer 2 schemes like DHCP and layer 3 schemes like BGP and layer 4 schemes like TLS, we kept repeating the same line over and over. We said, this isn't secure, but don't worry about it. We're going to fix it at higher layers. So we kept deferring the problem to higher layers, and TLS is that higher layer protocol that solves all of those lower layer problems. So TLS says, as long as the two people communicating on either end of the connection are secure, everybody else in the internet can be malicious, and we still get confidentiality, integrity, and authentication. That's a really strong property, but it's something that TLS provides, which is pretty amazing. So even if I am secure, the server I'm talking to is secure, and even if every other person on the internet, every router, every attacker is malicious, our connection can still be secure. That's pretty incredible. So why is that the case? Well, remember we saw the TLS handshake, and it provides confidentiality, integrity, and authenticity. Even if a man in the middle tries to tamper with one of the messages, TLS will catch that. And all of our messages are encrypted. So even if everybody's a man-in-the-middle attacker, they're doing DHCP attacks and BGP attacks, they still won't be able to read the encrypted messages that we send. So this is how we defeat all of those attackers at lower layers. We basically say that those attacks can happen, and it's OK because TLS will catch those problems that we talked about. So even if somebody who's on path tries to read our messages, they can't read TLS messages. Even if they try to inject TCP packets, those will not be accepted because they don't know how to create valid MACs. So we've stopped all of those attackers that we've talked about. Now, you have to be a little bit careful. Just because TLS provides end-to-end security doesn't mean that everything is magically solved. End-to-end security says that both endpoints have to be secure for the scheme to be secure. So if one of the endpoints is malicious, then you don't get end-to-end security. So for example, let's say I am talking to evil.com, the attacker server. Now, it is true that TLS provides end-to-end security. There could be attackers all over the network, and I defeat all of them. But I'm still talking to evil.com, so if they send me a virus, TLS is not going to help me there. So TLS provides security against network attackers. It does not help you if you're talking to someone malicious in the first place. So as an example of how TLS defeats man-in-the-middle attackers, this is the RSA version. Let's say the client sends the client hello, then the server sends the server hello and the certificate. Now, if the man-in-the-middle here tries to modify this pre-master secret, then the server would decrypt a different version of the pre-master secret. And now the client and the server think they have different versions of the secret. So when they exchange those MACs at the end of the handshake, they will notice that the client thinks the pre-master secret is one value. The server thinks the pre-master secret is a different value. Their MACs won't check out. So we've stopped the man-in-the-middle attacker. Also, if they wanted to read our messages, the attacker can't do that either because the pre-master secret is encrypted. So we've stopped the man-in-the-middle attacker in the RSA variant. And in the Diffie-Hellman variant, we can also stop the man-in-the-middle if they want to try the Diffie-Hellman man-in-the-middle attack, where you cause the client and the server to derive different keys. They can't do that because this half of the Diffie-Hellman exchange is signed. So if they try to tamper with it, the client will notice that it's been tampered with, and the connection will fail. And they also cannot derive the shared secret because the discrete log problem makes it hard to derive g to the ab mod p. So we've stopped all the man-in-the-middle attackers, whether they became a man-in-the-middle using ARP or DHCP or BGP or TCP. We've stopped all of them using TLS.